Okay, so we're going to spend some time on strings, so I'm going to create a new sub-package called strings. Put it in there. Okay, so the first thing this is going to be counting characters. Okay, so there's our test string. And what we want to do is we have this, we have this string, and we want to count the characters in it. Okay, so fairly straightforward thing. I mean, actually, if I gave that to you as a homework problem, you could all probably do it just using what you know already. But here's a very what I think is a very clean, in terms of the logic, way of handling that. So again, what we're going to do is define a map. In fact, let's sort them. So I'm going to have a sorted map, and when we define a map, we specify the key. The keys are going to be characters. The values are going to be integer. Okay, so again, my convention is to define the variables in the most abstract way that doesn't paint you into a corner. And so it's a sorted map is the interface, so I'm declaring the variable to be of that type, because sorted map, the interface, is going to have all the methods that I need. That is, tree map, as a concrete class, does have some additional methods to it, but in this case it doesn't have anything that I'm going to use. So if it does, sometimes a class, a concrete class, will have some methods that you need to use as part of that class. And in that case, you want to declare the variable to be of that type if you're going to use those extra methods that aren't in the interface. All right. Okay, so the first thing is to get the character array. Okay, so char is one of the primitive types that we talked about earlier. And now strings, and like I said, we're going to be looking at a lot of, look at all these methods that it has. So we're going to use toChar array, because notice that's going to turn this into an array of characters. But look at all these other things. So we have the character at a given index. So we can say, what's the character at this index? And that, of course, it's zero-based indexing, which always causes problems. These, code compare, so compared to, and then compared to ignore case. That's another interesting one. Concat, that's actually, well, we'll talk about how strings are immutable. We can actually get the things as bytes. So a byte is yet another primitive thing that the only time when we're going to maybe look at bytes is when we're talking about working with the file system. Anyway, but all that is in the future. I have a string, and I want to get the characters in that string, and I turn it into a char array. Now I have an array of these characters. Okay? So, and in fact, let's do a for each, just to see what we got. Okay, so there's our, there it is, just on each line. We're not going to use that, but that's just to make sure. But let's I actually probably just want to put that up here. All right, so just to say what that's the character, that's the string that we're going to be analyzing. Okay, so what's the strategy here? Well, now that we have each individual character, we're going to loop through those characters, and as we encounter each one, again, to think of the logic. Again, you're the program now, and how would you do this if you were doing it by hand? I mean, just in a logical way, maybe not the most efficient way, but you know, supposing you have anything like in let's say you're counting, you're an election clerk in Florida and you're counting the votes. Well, you take a ballot and you say, okay, if I you put a mark or whatever. And if it's a write-in candidate, then you'd have to say, oh, here's somebody who wasn't on the ballot, but we have to, put a mark, add an additional category for somebody who hasn't been there before. So here we have an empty map, and what we want to put in it is we want to put in the characters that we encounter, but as we encounter them, there are kind of two questions. There's a question we need to ask, and that is, have we encountered this character before? If we have, then the next question is, well, how many have we had before? And if whatever we had before, we want to add one to that, and now that'll be the new one. Okay, again, this is not complex logic, but still, without, and again, this is something that you could do, but this is kind of a nice way of doing it, and it's also one that kind of helps you understand how these maps work. So now we're going to loop through the character array. Remember, so what's the first question? The first question is, have we encountered this one before? That is this the first time finding this character or not? Now, we can ask our map this question, and the method is contains key. So contains key, and we give it a value, will come back true or false. It'll come back true if it contains the key. It'll come back false if it doesn't. Right? Okay, so here's a new method. And so what I want to do, okay, what I'm going to do is if we've encountered this, but we haven't, that is, we're looking at this new character, but we haven't encountered it yet, then what I'm going to do is I'm going to put 0 there, just to make sure that something is there. So this is one way of doing it. Thank you, NetBeans. All right, and why am I'm putting 0 there so that over here, once I come out, I'm assured that it's going to be in there. And I'll call this the old count. And now I can get the count of my character. So even if it's the first time encountering it, then this is going to return 0, and I know some of you would want to use the plus or whatever, and you got to be careful about that. I'll show you why in a second. But then okay, and again, this is not the most efficient way to do it, but I claim that this is the clearest way to do this. This is the way to do it in which my intent, the programmer's intent, is made as clear as possible. In other words, if you're reading this bit of code, I claim that it is absolutely clear what I'm trying to do. Even if I'm not doing it correctly, it's clear what I'm trying to do. Okay, so let's see what this does. All right, so now here's how we loop through it. Remember, there's the keys in a map are kept in a set that ensures the uniqueness. Remember, because sets can't contain duplicates. And which particular set is in here, we're kind of indifferent about it. So whatever we had. In this case, because it's a sorted map, that set that we're going to get is going to come in sorted order. So we're going to actually see how the characters get sorted. And then I'm going to use this printf thing, which is in the reading for strings, and which you've encountered it a little bit before, but even back when we were doing the cards, if you remember, there was that string format thing. And again, we'll talk more about it, but I'll just sort of use it. Okay, so what I want is my characters are going to be a string, and my values are going to be an integer, and then %n is the new line. And I want C, and I want counts get C. Okay, so this will be, let's see what that looks like. Okay, so here's the string that we had, and then here are the characters that it did, and then, okay, now what do you suppose is going on with this? That's the space. So we see that a space is a character. And everything that we see is a character. So, and then there's the exclamation point. That's a character. Now we see the capital N and then the lowercase one. So we see that the way that characters are comparing themselves is by this strange business. Now, to understand a little bit about why that's happening, each of these characters has an associated number with it. And that number is what's driving the order. So instead of printing them as a string, I can try to print them as an integer, but I actually have to cast it to an integer like this. So here, when I print this out, this gives me the numbers associated with each character. So remember, this was space. So space has a number of 32. Exclamation point was 33.
That's the ASCII key number that parallels in the array, or is that the count that was where it sits in the
Well, what's on the right are the counts. What's on the left are well, now it's not ASCII, it's UTF. But yeah, you sort of think ASCII for the sake of it. Correct.
Okay. And that set, so the set itself, we're looking at the set. Does it have like the full 255 characters, whatever numbers in there, and then for 32, 33, 78,
These are the only ones that are in this particular map, because so these are the only ones that I found in this particular string.
So if I return spot 0, it's saying all.
Yeah, in fact, let's, yeah, so now here, there's that wrapper business for, so if I say, now wait, for 0, which is going to be counts get, okay, now here's the character 0. Let's see this. Yeah, so it's I'm sorry, this would be an int. Okay, yeah. Okay, so now, just as I did something like this yesterday, and since you remember everything that I say, what's going to happen here? And it's a little bit subtle. Right, yeah. It's going to, if you get something, if you ask a map to get something that it doesn't have, it returns null. But there's something more going on here. So let's print that. Now, what's going to happen is we're going to get a null pointer exception. We're actually not going to get a null. Well, we are going to get a null, but it's going to produce a null pointer exception, which, let's see, yeah, there it is. Okay, and the null pointer exception is right here where we're trying to get this. Now, do you remember why I got a null pointer exception instead of just getting null?
Because the set wasn't built for 0. So the map doesn't have that 0 spot built in. So the
That's true, but that's not why I got a null pointer exception. Now, what you said is true. Again, that's why I said this is a subtle thing. It's because of this auto boxing that Java is doing under the hood for you. So remember, the contents of the map are these object wrappers. So the value in this case is going to be an integer capital I, not an lowercase I. So what it does is, what counts does is it says, okay, get, in this case, a primitive char. And it says, okay, I see you're trying to get a primitive char. My keys are character objects, and that's compatible. So I'm going to box that up. I'm going to wrap that character, this 0 character, in a character object, and then go searching for that key. So the key, the character object that is associated with the 0 character is the key, and it goes looking for it and says, I don't got it. So if it had it, like what it did over here, I'm basically putting that into a primitive int. And what it said is, okay, I found it. I returned an integer, capital I, but the context at which I'm printing this is actually int primitive. So I'm going to unbox it for you. So I get it. The return from this is integer, capital I, but the context I'm using it is int, and so it gets unboxed and put in place, no problem. But how do you unbox it? How do you unbox it? By invoking a method. That method, in this case, is int value, but they have int value, double value, etc. These are all methods, instance methods, that these object wrappers have. So let's unpack this a little bit. So get, once it wraps my key here, it goes to get it and it gets a null back. And then it tries to unwrap the null and therefore gets a null pointer exception. So in this case, so it doesn't have to do with whether or not that's there. If I get an integer, it will print it. And of course it prints null, but which isn't what I want either. So
the %d just refers to the corresponding value or the corresponding variable that you want.
yeah. It just, if you remember a while back, I didn't comment on it very much, but it was there was like a string format thing for your, I think for the cards. And in the strings chapter, they talk about this printf formatting. So that we'll go into that a little more detail. Basically, %d is an integer. %f, %s, the way we were doing it before. See, if I try to do this, I'm gonna get errors because illegal format conversion. I'm trying to convert a character to an integer, and it doesn't do it automatically. So, but if I do it as a string, what it'll do is it'll handle a character as a string, and that's how I do that. We'll get into that a little bit more. But the point here is now, again, this to me is, even though I used more lines than I could have abbreviated this whole thing. What I did here, again, to recap, I first checked to see if you don't contain the key. If you don't contain the key, then that means that it hasn't been encountered before. So my strategy here is if I haven't encountered, I'm going to push a 0 on it. I'm going to put a 0 on it, knowing that I'm going to immediately increment it again. And again, this isn't, there are slightly more efficient ways of doing this, but are less clear. And again, you could have abbreviated this whole thing, and if you were clever, if you were smart enough to do the plus plus on the right side, then it would have been a little better. Here's the danger, by the way. Let me show you what would happen if you're not. So here's a C old count plus plus. So people who like the plus plus, right? Makes sense? But okay, what went wrong? Remember I said plus plus is evil? This is one reason why. Okay. And you look at this code, that makes perfect sense. In fact, the intent is absolutely clear if you're into that. It's absolutely clear that I'm, yeah, exactly. Yeah. Yeah, exactly. This is one of the subtle things about this plus plus and minus minus operator. The value of this expression when it's in a postfix, when it's on the right-hand side, is the old value. So even though this variable does get incremented, but the value of this expression is the old one. And that's really subtle. If you're looking at this code, especially if it's stuff that you haven't written, that's going to be really hard to find. That's why I don't like these. Now, having said that, you are absolutely correct. If we put it here, now the value of the expression is the new one, and this will work. So now we get the counts. Okay, but this is why I don't like this. So here, with this code, there really is very little that can go wrong. And in fact, I could have even put this +1 or whatever. I didn't need all that. Again, that's what I'm saying. This isn't the most efficient. I'm declaring extra a variable, local variable that I that I don't necessarily need. But what I'm saying is that anybody who reads this is absolutely clear about what I'm trying to do. There's no doubt about that. And this is not the most efficient code. However, Java does have a lot of optimization under the hood. So I'm fairly confident that the Java, either the compiler or the virtual machine, is going to look at this code and say, boy, this guy's an idiot. I can make this go faster. And it will. So, knowing that either the compiler or the virtual machine is going to do that, I'm freer to just kind of write things, maybe in a less of what may seem to be a less efficient way, but when it comes to executing, it is actually not.
So the guys at Java, do they work all day to make the Java virtual machine better? Do those things, or look like?
Oh yeah. And actually, it was actually the C compilers that were the groundbreakers in this, because let me turn this off because I'm